Good morning, lovely tenors. Right, buddies, here we go. Still rocking on in our amazing sampling unit. And this is a bit cool because those of you who really like science and biology specifically, we don't usually do a huge tie-in with biology and maths, but you'll like this topic. Please put the title Capture/Recapture Method. Yeah, you'll like this. Biologists use this all the time. I've seen this in Canada lots. I'm not sure if I've seen it too much in the UK, but I'm sure they must do it here too. And here's what it is. You can figure out how many of a certain type of animal there exists in the wild. So we're all quite excited if we see something like a fox or something out in the wild. You're like, oh, good, it's a fox, and you point at it, right? And you're like, oh, that's a special animal to look for. And yeah, we all get a bit excited. But have you ever wondered, oh, I saw that one fox there. Are you ever like thinking to yourself, I wonder how many foxes actually live in my village or actually live wherever? Do you see what I mean? You could actually figure out how many foxes that there are. And this is where this method comes in. It's called the capture-recapture method. You can figure out how many fish there are. They use it for that all the time. That's the animal I've seen most tracked out of anything else is fish in Canada. They figure out how many fish there are in a lake or whatever, and this is what this method is for. All it does is it figures out how many fish there are in a population, how many animals there are in a population by presuming that the sample that you take them from, the sample of the fish that you catch to look at, is the same portion, will match up portion-wise with the whole population. So yeah, that's what it is. I just put a couple pictures here for you to look at too. There's a picture of a whale with a tracker attached to it. I bet you've seen this a lot. There's a bird with a tag on his leg there, penguin with a band thing on his arm. I have no idea what that animal is, but it's wearing a collar. All of those things are put on by people so that they can research the animals with the end goal of kind of preserving their health and making the population good. So I know it probably sucks to have a collar on, but yeah, it's going to keep that species going. Yeah, happy days. Cool. Now, here's what we're going to do, buddies. Here's how a capture-recapture works. So, oops, sorry. The first thing you look at then is you're going to take a capture of animals, okay? So here's what you're going to do. We're going to go out and we are going to dip our fishing line in the water and we are going to catch 20 fish, okay? Now, every single fish that we catch, we're going to put a little tag thing on its like fins, okay? So we're going to put a little tag on the fin so we know that we caught that one, but we're not going to kill the fish. We're going to take the fish then after it's got its tag on and we're going to let it go again, and it's just going to go about its day, but with a tag on it. So now it's just a fish out with the other fish in the water, okay? So here's the thinking behind that. The number of fish that have a tag on, so this is what this part is, this is the capture, catching them the first time. The number of fish that we put a tag on will be all the fish that we catch. Now, we don't know how many fish there are altogether, but we know the number of ones that we catch are going to get a tag on out of however many that there were in the whole population. So we put a tag on 20 fish out of the 2,000 fish, for instance. 20 of the fish we caught, so 20 of them got a tag, but we don't know how many there is. Cool. Now what we're going to do is we let all our fish go, we go about our day, the fish go about their day, and a few weeks later we come back and we dip our fishing line in again, and we start catching the fish again. Now, what's going to happen now is I'm going to start catching fish, but I'm not going to catch the same ones necessarily. I'm going to catch some fish that I didn't catch the first time. So, say I catch 20 more fish, but maybe then only 3 of them have been caught before. Well, that means 3 out of 20 of the fish is the proportion of fish that we caught the first time. That should be in proportion to the total number of tagged fish to the whole population. Does that make sense? In the second capture, the recapture, we should get the same portion of fish with a tag on as was the original portion when we were putting tags on them out of the whole population. Now that sounds tricky, but it won't when we get some numbers to it. So make sure this is in your notes. So if you haven't written this part down yet, please do, and just pause I'm going to switch the slide in a sec, so just pause the video if you've not written this yet. So pause now, and now that you've written that down, let's try a question. This is like a real life question. So there they are. I've seen all this stuff in real life. My sister does this actually. She's a biologist, and she tags fish. That's part of her job as well. So this one's got a little bit of like a lip ring thing on it, and this one's got one of those ones that are just under the skin, and it's like going to be a little radio one that they can find the fish better too. Cool. So anyway, yeah, here we go. Let's do it. Okay, 10 fish are caught in the lake and marked and then released back into the lake. A week later, 20 fish are caught, and 4 are found to have been marked. Estimate the number of fish in the lake. Now here's what you're going to do then, buddies. To start with, I've even color-coded it for you. What's in red is the first capture, okay? So here's the thing. Here's the capture. We got 10 of them, right? So we caught 10 fish out of the, I don't know how many fish. I'm going to call it N. N, the total number of fish in the population, okay? So there were 10 fish that we tagged, or sorry, 10 fish that we caught out of N fish in total, okay? Get me? Total population. So we caught 10 out of the total. Now here's the thing. What that's going to equal to then is going to be, the next is going to be equal to the sample. So a week later we caught 20 fish. This is going to be out of 20. And how many of them were tagged? Well, 4. This is all that capture recapture is. It's 4 out of 20 because 4 were caught before, and that means 16 new ones were caught, so it's 4 out of 20, the ones that we caught before. Now we're just saying these two portions are the same, and all you're going to do now, my buddies, is you are just going to figure out what n is, and that's the answer to the question. Now, most people teach this with something called cross multiplication. So you go like that, and you go like that, and that gets rid of the fraction. But I'm going to, just to support the last thing I did, I'll maybe do it that way in the next one, I'm going to ask you to support the last unit. What can we times both of these fractions by in order to get rid of the fractions altogether? Well, what you do is you bodge the two denominators together, and we're going to times both sides by 20n. Same as when we did those really hard fraction questions together. It's the same as that, because then you can scratch them out, and the same deal here. And on the left-hand side, all you're going to be left with is 10 times 20, which is 200. Cool, and it's over 1 because the n's are gone now. And on this side, what you're going to get is you're going to get 4 times n, so it's going to equal 4n. Cool, divide both sides by 4, so over 4, and you're going to get then 200 divided by 4 is 50. Cool, so there you have it. If we caught these 10 fish out of the total population, and then the second time we caught 4 fish out of the 20 fish, if those proportions are meant to match one another, then it means there must have been 50 fish altogether in the whole population, because a quarter of them were tagged, and you're going to take a quarter of, yeah, I'm not going to make it too complicated. I'm going to stop making it complicated. N is 50. I hope you get that. Cool, cool, cool. Sweet. Okay, let's make sure we really do. Next one. Oh, this is cool. Yeah, these guys, they're snails with tags on, so these must be some sort of like special snail. They might even be water snails, I don't know. But it's like, yeah, they've got tags on, so you can tag a snail. And this is a giant African land snail, and I promise that picture is not photoshopped. That is actually like a horrendous, enormous, disgusting snail that kind of looks like a bunny. How exciting. Okay, anyway, let's try this one then. Cameron wants to know how many snails are in his garden. He collects 5 of them and he marks them. Then he puts them back in his garden. So that's the capture. A few days later, he collects 10 snails from his garden and he finds that 2 of them are marked. Find the total number of snails in Cameron's garden. Okay, here's what I want you to do. I want you to pause and do that all by yourself. Go. Okay, and you are back. So let's see how you've done. Well, here's the thing. The capture, we're going to say that we got 5 of them. So we got 5 of the snails in the garden, but we don't know. I'm going to call that n. You can call it x if you want. We caught 5 of them, but we don't, out of how many? We don't know. So it's 5 out of n, so we don't know how many is actually in the garden. Now, what that's going to equal proportionally is this. When we recaught them, 2 of them we found were marked. 2 of them out of 10. Cool beans, buddies? What we do now is we just kind of sort it out. We're going to times both sides by 10n because that's the 2 bottoms smashed together, because then you get to go and and on this side then, 5 times 10 is 50. And on this side, 2 times n is 2n. Divided both by 2, n is 25. So he should have 25 snails in his garden. So I hope that you got that right. Again, it's just a matter of knowing how to lay it out and understanding that the 2 proportions are equal to each other. Now, because this is a bit of a science question, a little bit more of a bio, which I love science so much, but it's a science question, so we do need to actually say sentence answers occasionally in a science question. And here we go. It says this. It says, state two assumptions that must be made in order for this estimate to be as accurate as possible. Now, it's kind of the same assumptions every time. Why is it working is really the question. Well, what has to be true of the snails then? About, you know, I set them equal to each other, right? Here's what we've assumed. We have assumed that that the proportions are equal. That the proportion of snails, snails recaptured is the same proportion as in the garden. Okay? Essentially, it's just saying we're assuming that the sample represents the population, which is just like what we were doing when we did stratified samples and random samples and systematic samples last time. Okay, we're assuming that the sample matches the whole. That's what this is. It's just assuming the sample matches the whole. The proportion of snails in the recapture matches up with the snails in the original garden. Cool, so that's the first assumption. And the second one is you got to assume that the snails can't leave or that new ones don't come in because, say, I don't know, you had a really snail-friendly garden, you might get tons of extra snails in it, which would make our estimate all mixed up because maybe there's only 10 snails last week, but now there's 200 because you put something in your garden that snails like. I don't even know what snails like, but yeah, there you go. So you also assume that no snails came into or left your garden. Okay, that's the other assumption. And I'll give you a hint. The answer is always that. So whenever they ask you a question, those are always the two answers, okay? You assume that the proportion matches the whole, and you also assume that the snails can't come or go. And guess what, buddies? That's it. Nice, easy, quick one today. That's not even under 15 minutes, that lesson. Your only activity that I'm going to get you to do, too, it's not going to be too bad of a one, is this here. It's on another PowerPoint, so I'll save it as a Word document or something for you. It's a code breaker, okay? So it's just a code breaker, and this is it. It's the same thing, okay? Transporter on the platform for an hour, records the number on the front of the trains, goes back the following day, blah, 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 blah. See what I mean? It's just capture, recapture. All of them are just the same as each other, but you need to do them for practice. There's 8 of them. The minimum steps you need to show are these steps, okay? 1, 2, 3 lines. For every single one, 1, 2, 3 lines, and then grab the joke or whatever it makes at the end, and you can figure out about teachers and monkeys and suspense and stuff. It'll be amazing. I'm sure it'll be hilarious. I can't remember what the joke is, but yeah, happy days. Cool beans, buddies. Well, that's it for me. Have a lovely, lovely, lovely day, and see you soon. Goodbye, my lovelies. Bye, buddies.